Okay, so we're going to go over system of equations and explain how to find the solution. So in this case, we're going to go over a linear set. And the linear set of equations are, it could be two equations or more. So it just has to be at least two equations. So if we had something like x minus 3y equals 4, and then we also had 2x plus y equals 1. What we find is this is just different ways of writing the line. We don't have to say y equals something. We can have y and x are variables on both sides. But if we balance these, or not balance, but we equate them and solve for y, what we'll find is that this one turns into y equals 1/3 x minus 4/3. So that's just solving for y. And now if we solve for y on this one, now what we find is we actually have minus 2x plus 1. Okay, so we could just graph these. You know what, let's wait for a second. What I've seen here now is that they both equal y, so this equals y and this equals y, so they must equal themselves. So I have 1/3 x minus 4/3, and that has to equal minus 2x plus 1. So if I solve for x, so in this case I'll add 2x to both sides and I'll add 4/3 to both sides. What I get is 7x over 3 equals, and now I have plus 4, that's 7 over 3. So that means x is equal to 1. So now I have this possible solution. So I could go back to this equation and put it in and solve for y. So now I'm going to go back to this one, and I have x is 1 minus 3y equals 4. So if I solve for y, what I'll get is y equals minus 1, right? So that's what we get. So now we have the point 1 comma negative 1. Now why don't we go check that into this solution? So we're just checking. This is a check. And we're going to check again to see that it satisfies the other equation. So now it's 2 times 1 plus negative 1, and that has to equal 1. So that's 2 minus 1 equals 1, and that is 1 equals 1. So it works. So this is an intersection. So now what we could do is we can go to our graph. It was a very straight y-axis, but that's fine. So now if I want to graph this, I go up to 1, and I know it has a slope of negative 2, but I also know that when x is 1, say that's 1, this is my point of intersection. So I actually know the line is quite steep. Just put that there. So this is y equals minus 2x plus 1. And now if I go to this one, I actually have a very narrow line, and at negative 4 over 3 is its y-intercept. These are the y-intercepts. And it has a slope of 1/3. So when y is 0, x is going to be 4. So we'll have 4. So this is its x-intercept. So it goes like this. And it has a very shallow slope. And this is our point of intersection. So that is our solution. So this is now y equals 1/3 x minus 4/3. So we've gone through, we see that there's one solution. Is there any type of equations for linear systems where there might not be any solution? And that's true, there is. We can have one solution, which is like this, 0 solutions. And that's when the lines are parallel. They'll never touch. So then there's also another possibility, and that's an infinite set of solutions. And that's when the lines just overlap. So there's just two lines over top of each other. And they might just be written in a way that it doesn't look like they're the same line. You might have something like this. So this is equation 1, and this is your second equation for the system. But these are identical lines, so they actually just superimpose. They're on top, so there's an infinite set of solutions.